Dr. K. Paranivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the lecture series on aquatic chemistry, and today we are going to discuss about one of the important topic, namely chemical speciation. The outline of the lecture will be about what is the chemical speciation, its importance, toxicity and bioavailability, and then what are the analytical schemes available for determination of this chemical species, etc. we will discuss during this lecture. So, to tell about what is chemical speciation, it is determination of individual concentration of the various forms or species of an element. That is actually called chemical speciation. That is, it applies to trace metal and metalloids, especially for heavy metal. This chemical speciation is most particularly used, and it is defined as a different physical and chemical forms of a particular substance of a metal which may exist in the environment. So, that is actually called chemical speciation. When considering water sample, this include not only the truly dissolved metal ions, that is as a free metal ions or the complex aqua complexes, but also colloidal forms of the metal and any metal contaminated within are adsorbed onto other suspended particle. So, it includes everything. Okay. Why this is important is because the toxicity varies, bioavailability varies. Not only this, the solubility of compounds and the volatilization also varies depending on this, each one of this. So, mainly the toxicity, bioavailability is a very, very important why this chemical speciation is paid lot of attention by the environmentalist. We all know, just consider nitrogen, it exists in different oxidation state and the different forms. Nitrogen can exist in different oxidation state from -3, 0, +3, +5 as ammonia, nitrogen molecule, nitrite and nitrate. Similarly, phosphate in water and wastewater also occurs similar way in phosphine, phosphorus and more importantly phosphate. The phosphate as H3PO4 phosphoric acid, depending on the pH, 3 species may be available in natural aquatic environment. In a slightly acidic condition, this will be present as a phosphate, or this compound, or more acidic condition, this will be the species as shown in this diagram. Depending on the pH or the pK value, what species it will be present also can be determined. Okay. So, at a highly alkaline condition, this is a phosphate will be available, and in a slightly neutral condition, this species HPO4 3 is a species, and in a more acidic condition, this will be the species with a mononegative H2PO4 minus, and the strong acidic condition, that is below pH 2, its undissociated phosphoric acid will be available. So, like this, based on the pK value of these compounds, depending on the environment, any one of the species may be available. So, we can find whether phosphate is available in this phosphate form or this form or this one. Okay. So, it is all depending on the pK value, as we discussed for carbonic acid. And in seawater, the phosphate species, suppose consider, because you have variety of calcium, magnesium, sodium, all the species are available in seawater, all these phosphate how they associate it. Determining this is very, very complicated. Depending on the magnesium content it is available, and calcium content, and sodium, and acidic condition, etc. What is the component available is very, very difficult to determine. All the species have been identified in seawater for phosphate, and this heavy metal speciation is nowadays because of the important. The chemical speciation, even though we used to distinguish nitrate, phosphate, and nitrite, etc., but this is mainly applicable to heavy metals. Already we discussed what is heavy metal. That is metal with atomic number more than 20, density greater than 5, and at the same time they should be toxic. So, metals like mercury, lead, chromium, arsenic, and including non-metalloids like arsenic, antimony, etc., and even lighter elements, the density is less than 5 like aluminum, also part of this heavy metal group. So, the chemical speciation is very much important for this toxic metal. Why this is important? Chemical speciation is paid much attention because of these reasons. For example, consider mercury. Mercury can available in the metallic mercury with a zero oxidation state. This compound is considered to be inert and non-toxic. At the same time, it is highly vaporizable. Mercury can escape into the atmosphere very easily, and it becomes highly toxic suppose we inhale. And we have mercurous 1 ion, Hg, H2, that is mercurous ion. This is low toxic in nature. Suppose if it is available in the environmental samples in a mercurous, mercuric, mercury with a 2 plus oxidation state, this is toxic in nature much more than the previous one, but not easily transported across biological cell membranes of living things. And mercury also can present in the organically bound form, because mercury is a type B metal which can form organometallic compounds. So, methyl mercury compound is one of the important organometallic compound. This methyl mercury compound is highly toxic, that is the main reason, and this is easily transported across biological membrane. Not only highly toxic, it is easily transported across biological membrane because of the fat soluble nature, more lipid nature. And mercury also, under stronger methylating condition, it forms dimethyl mercury, which is relatively low toxic compared to the monomethyl species, but it can be easily converted into monomethyl mercury species under acidic conditions. The dimethyl will undergo easy hydrolysis, forms monomethyl again in the acidic environment. So, if you look at mercury, all these compounds are possible. In fact, the chemical speciation work in environmental field started with mercury. The Minamata incidents happened in Japan Bay in the year 1952. So, from then onward, people invented this species, monomethyl mercury species is a main culprit for this. That time onward, the interest on chemical speciation work started. And look at mercury and all this toxicity of this compounds very widely. And consider a metalloid like arsenic. This is again the toxicity varies. Arsenic in normal samples may present in the arsenic 3 trivalent form, arsenic 5 pentavalent form, monomethyl arsenic, and dimethyl arsenic. So, arsenic in normal samples although have found to be available in all this form, but if you see the toxicity, trivalent arsenic is more toxic than pentavalent, and the toxicity in fact decreases in the order. Arsenic 3 is more toxic, arsenic 5 less, whereas the organically bound arsenic are less toxic than the inorganic counterpart. So, if we look at mercury and arsenic, organomercury are more toxic, whereas organo arsenic are less toxic. Even consider chromium in the normal samples. Chromium in the hexavalent state is more toxic than the trivalent form. This is again thing. So, the toxicity of these compounds vary widely, okay, and their bioavailability also. In the bioavailability, just look at I want to tell you the main example. iron deficiency in human beings is one of the reported things. Okay. And for this, iron tablets are advocated, and normally the iron is present in the organically bound iron citrate type of compounds are used as a iron supplement. Suppose we take inorganic, definitely it is not bioassimilable. So, the organic part of the iron is prescribed as a to increase the hemoglobin content of the body. So, like this bioavailability also varies for different compounds. So, mercury is the one, mercury and the fish is the main thing all the chemical speciation works are started, because the mercury whatever released in the electroplating industry or chloroalkali industry, the mercury ion is discharged from the anode, comes into the being where anaerobic condition, where methylating organisms are there, they promote the dimethyl organic mercury or monomethyl organic mercury, and that is all easily transported into the fish, because the very easy transport across the membrane and all bioaccumulated, and it is all. So, the mercury species transformation, as already told you, is easily converted to the monomethyl mercury and dimethyl mercury and gets enriched in the fish lipid, and concentration more than 1000 times it is all exceeded bio concentration, and the monomethyl mercury becomes highly toxic, and the methylating agent is vitamin B12 is a. So, the speciation study is in connection with the transport of each species in the aquatic environment will be different, and they will also have different toxicological properties. And if you generally if you look at it, behavior of metal ions within an aquatic stream and in the associated sediment is very widely in the transport properties depending on what is the type of metal ion. Usually metal complexes have lower toxicities than the corresponding free metal ions. Okay. Any particular metal ion is complex, this is general thing statement, is less toxic than the free metal ion. The free metal ion mobility is also very high compared to the complex, and if the metal ion has more than one stable oxidation state in water, there may also be even differences in behavior between the different oxidation state of the toxicity. For example, as I mentioned before, chromium and arsenic, hexavalent chromium is more toxic, trivalent is less toxic, whereas if we consider arsenic, trivalent is more toxic, pentavalent arsenic is less toxic. So, the toxicities of these ions also vary, and especially any metal with a very high oxidation state in aquatic stream, they will be available as a anions. You take arsenic, it will be as a arsenate or arsenite, take chromium, chromate or chromite. And if you look at the species of chromium speciation, and as with the pH-P diagram, the electron activity in the y axis and pH species is shown, how this chromium species are present, especially in the trivalent and hexavalent. Under aerobic condition, chromium will be present as a chromate anion at high alkaline pH, and lower condition it will be present as a chromate or dichromate, even a very high acidic condition it will be present as a dichromate anion. So, all the chromium are present as a anionic species because of the high oxidation state. Even there is a interconversion is possible, and the lower condition, lower redox condition, and at a lower pH, all this chromium will be present as a chromium 3, and it is also very easily the intermediate zone. If we consider, hexavalent chromium is a very powerful oxidizing agent. So, even in presence of small traces of organic and other impurities are present, that will be reduced to trivalent chromium also. So, easy conversion is possible, whereas the reverse is not true, that is the oxidation of trivalent to hexavalent is very difficult. Okay. So, in aquatic system all the chromium will be available in depending on the either aerobic condition or anaerobic conditions. And not only for chromium, any speciation studies, the pH-P diagram, that is Faubourg diagram is very useful to find out this. For all the elements, it is all recorded in the literature. What is the pH and electron activity? We can predict what is the species likely to be present. And just consider another highly toxic metal lead present normally in the normal sample of a river water system, and we can see there are variety of diverse species of lead is likely to be present in a typical aquatic environment like a river. Some of the species and the associated forms are free metal ion like lead is available in the solution form in the river system, and it can be available as an ion pair like lead bicarbonate, that is again in the solution form, soluble form, and it is also available complexes with organic substances like EDTA, lead EDTA. This is also available in the solution form, soluble. And consider the high molecular weight fulvic acid lead can interact with the fulvic acid, and this is actually available in the suspension form, not in the solution form. The first three in solution form, whereas lead with fulvic acid in the suspension form. Also, lead may be adsorbed to the ferric hydroxide in the colloidal form, that is ion absorbed onto the colloids of ferric hydroxide, and lead also may be within the decomposing organic material, that is lead in organic solids normally occurs as a solid form, and ionic solid normally held in lead held in solid in the ionic solid form, also with lead carbonate is another one normally available in the solid form. So, in a river aquatic system, the lead species depending on the nature may be available in the solution form, the first three, in the suspended or colloidal form these two, and in the solid form in the remaining things. So, variety of chances are possible depending on the circumstances, what are the other surrounding environmental species are there, and depending on the again the system in the aquatic system, all these chemical species are possible of a metal ion, that is a hydrolyzed one, and other complexing agent, whatever the things present, accordingly the different variety of metal ions and the species may be present in the aquatic system as shown for lead. Other possibilities are highlighted here. Apart from this toxicity and bioavailability, the speciation, chemical speciation is also very important in water treatment. Just consider the two issues, especially in the groundwater, arsenic and iron removal is a major problem. Okay. Especially arsenic in our India, West Bengal state, where many of the groundwaters are contaminated with the arsenic. So, the arsenic removal is very important because of the high toxic nature, and it is very important whether arsenic is present in the arsenic 3 or arsenic 5, because arsenic 5 can be easily removed with the help of aluminum ion precipitate, because arsenic in the pentavalent easily form aluminum arsenate or iron arsenate and gets removed very easily with the precipitation or adsorption with this compound, very easy. Suppose arsenic 3 is present, it is very difficult to remove this. So, it is very important to know what type of species are present of arsenic, and usually groundwater may contain arsenic 3 because anaerobic condition. So, first what you have to do is, in this type of arsenic is available arsenic 3 form, it should be oxidized with a chlorine or other oxidizing agent to arsenic 5, then it should be removed as a aluminum or iron insoluble precipitate or aluminum or iron based oxide as an adsorbent, and nowadays lot of work is going on with a nano sized iron or aluminum, which is very effective for the removal of arsenic. Same thing with iron. Iron in groundwater usually available in the ferrous state because of the again anaerobic conditions. The moment if you take it out, iron will be converted into iron 3, which is insoluble in water. So, the iron in groundwater should be removed, usually simple way aeration, simple exposure to oxidation of atmospheric oxygen will convert this ferrous to ferric, and that will lead to ferric hydroxide formation and that can be removed easily with the sand filtration. So, aeration followed by sand filtration is sufficient to remove arsenic ion, but we should know what oxidation state. If it is straight away present as a ferric insoluble, only sand filtration. If it is ferrous, definitely the combination aeration and sand filtration. Same thing with arsenic oxidation. We should know what are the oxidation state or chemical species actually it is present. Chemical speciation or determination of what type of species is very, very important, because it tells you about toxicity, bioavailability, and sometimes treatment need also. So, prediction of the species based on thermodynamic modeling is also available. You just measure pH/pE diagram, and based on that we can find what type of species is likely to be present with the help of modeling that is possible. And another thing is as determination of species in real samples using an analytical established analytical scheme. This is an actual determination of what are the type of species present. And the analytical scheme is, again, there are simple scheme and much complicated scheme are available. The simple scheme include filterable and non-filterable fraction of the material. So, what type of forms are in the dissolved form, and what type of things are associated with the colloids or suspended impurities in this. So, that is with the filtration determine what is the total concentration, and the non-filterable dissolve it and find out what is the total metal concentration this is. Okay. So, this is the first step I can say in the simple speciation scheme. And similarly, labile and non-labile fraction of metal ions with the anodic stripping voltammetry. Okay. That is also possible. So, in the metal ions whatever is directly undergoes cathodic reduction followed by anodic stripping voltammetry is possible, and we can distinguish labile and non-labile fraction also. And nowadays also by exposing to UV oxidation also thing. So, all these schemes are simple scheme. We can fractionate into two groups of metal ion, but when you want to find out including what are the chemical species, organic components of a different like a monomethyl, dimethyl, arsenic or mercury, we have to go for a complicated scheme actually intend to distinguish many more fraction of the particular metal ion, which is actually the real chemical speciation of species. Determining, suppose mercury means monomethyl, dimethyl, inorganic, mercurous, mercury, metallic mercury, all is actually chemical speciation. Similarly, in arsenic, arsenic 3, arsenic 5, and then monomethyl, dimethyl arsenic species, that is actually chemical speciation. So, determining as a group, as I mentioned before, is possible, that is determine each species individually. Those with the similar environmental transport or toxical properties could be analyzed as a group, and here a simple classification of metal species would go into two things. One is organic solvent soluble, extract with the organic one, and other category is organic solvent insoluble fraction also we can distinguish. That is the organic solvent soluble, if you see neutral complexes of metal ion and organometallic species accumulate in fatty tissues in a similar manner to neutral organic compounds. So, this is much more toxic we can say. So, that fraction whatever can be extracted into organic solvent is a one. The other one is organic solvent insoluble. This is more of water soluble, and charged complex species or free ions comes under the category, which are all very difficult to extract into organic solvent. So, by this way also we can determine as a group. As I mentioned before, anodic stripping voltammetry is again or used for distinguish whether it is amenable for cathodic reduction straight away or attestum. That is labile and non-labile fraction we can distinguish with the help of anodic stripping voltammetry. And here again, as I mentioned before, two steps procedure would be to perform analysis on sample with and without UV radiation also possible, and value of the free metal ions or more precisely the total anodic stripping voltammetry, that is a labile content and total metal content with the UV irradiation before and after. That also will give you the some more fraction of the metal ions associated. And using different analytical techniques, we can determine the response of each one of the analytical technique. For example, with atomic absorption as a technique, most commonly used for determination of metals, atomic absorption spectroscopy, and all the metal species in the sample, that is the total metal is determined only here. It will not distinguish whether it is present as a different fractions or something. It will tell you the what is the total species. Suppose we go for visible spectrophotometry, that is also can be used. It is a low cost technique. This also can be used for speciation. This will give you what are the free metal ions plus ion released from complex by the color forming reagent, that is also possible. Similarly, as I mentioned before, anodic stripping voltammetry, liquid chromatography, gas chromatography can be used to determine organic fraction of metal ions associated with this. And we can distinguish the oxidation state also. For example, chromium can be determined with the diphenyl carbazide spectrophotometric determination, in which hexavalent chromium alone will answer. And suppose you want to determine chromium 3, it has to be oxidized with the sodium peroxide or potassium permanganate, then determine as hexavalent chromium. So, one with the oxidation, one with that oxidation will tell you hexavalent chromium content and total chromium content. Similarly, iron 2 plus 110 frotherine will give you iron 2 plus straight away. Fe3 by using hydroxylamine hydrochloride can be determined, that is reducing agent, and then determined using the 110 frotherine ferrous, or directly by thiocyanate, it will give you the blood red color. So, by this way we can distinguish chromium and ferric. Similarly, arsenic can be hydrate generation can be used for distinguish arsenic, selective reduction at 1 and 5. 5 will give you arsenic 3, 1 will give you the total arsenic 3 and 5. And also we can go for distinguishing the fraction of arsenic with the chloride extraction and arsenic 5 with the iodide, and monomethyl and dimethyl arsenic also with the iodide extraction, because all these things by combination of chloride and iodide at appropriate suitable acidic condition we can determine this fraction also. Mercury also can be speciated with the cold vapor, atomic absorption or atomic fluorescence, popularly used for this determination of very low concentration, either using stannous chloride reducing agent and sodium borohydride as a reducing agent. And monomethyl mercury can be also be determined by controlled in the acidity of the reduction of this reagent for determining this mercury species. And we can distinguish the fraction associated in the sediment or something is one of the very important speciation scheme proposed by Teissier sequential extraction. We can distinguish exchangeable related to carbonate and iron oxide or organic matter total etc. By using selective extraction agent we can distinguish exchangeable or carbonately bound or iron and manganese oxide or organically bound or residue things by appropriate reagent. So, by this way we can distinguish what are the different type of metal ions by this technique. So, to sum up, chemical speciation is very important, because the metal toxicity, bioavailability, volatility, solubility widely varies for different metals depending on the environmental circumstances, and it is very important to distinguish and determine what is the different chemical species of a particular metal. Total metal concentration is no longer environmentally significant, because already we have standards for chromium, arsenic and all different standards have come up. So, it is very important to distinguish what are the chemical species actually present in the environment. With this we have come to the conclusion of this session on chemical speciation. Thank you.